Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2024. Question number 3 is on the topic of waves. Electromagnetic waves are grouped according to their wavelength and frequency. Electromagnetic waves are transverse waves and can travel through a vacuum. Give one other property that is the same for all types of electromagnetic waves. So electromagnetic waves have the same speed in a vacuum or in air, and they all transfer energy. Any one of those points will give you a mark. 3.2. What is meant by transverse waves? Transverse waves are waves in which the oscillations of the vibrations of the particles are parallel to the direction of the movement of the particles. What that means is, if this is the particle in a wave, the particles move up and down. That's the particle movement. And the wave moves perpendicular to the particle movement. This is the wave or energy direction. Now, here's the answer. The oscillations or vibrations are perpendicular to the direction of energy transfer. Now, while we are on transverse waves, remember longitudinal waves. Right? The particle moves parallel to the direction of the wave. So both the particle movement is parallel let me get rid of that. Parallel to the direction of energy transfer. Now, the common mistake most students make is that they forget to mention that is direction. They fail to compare the vibrations to the direction of the energy transfer. Most answers that we see is that they say that the particles vibrate perpendicular, but they don't compare that to the direction of the energy transfer. Which group of electromagnetic waves is used for satellite communications? Satellite communications are usually done using microwaves. Visible light is the only group of electromagnetic waves that the human eye can detect. Which color of visible light has the shortest wavelength? That would be violet. So the longest wavelength on the other hand is red color. Right? Remember that in the electromagnetic spectrum, we start with radio waves, infrared, visible light, UV light, X-rays, and then gamma. So in visible light, the closest to infrared is red color. So if you remember the order, then it's also easy to remember which type of color has the longest and the shortest wavelength. And UV light is very similar to blue light, so it's violet in color. The three highest frequency groups of electromagnetic waves are hazardous. Describe a link, risk linked to each group of high frequency electromagnetic wave. So the three highest frequency groups are UV, X-ray, and gamma. So you need to identify all three of this for a mark, and then you need to describe a link, risk linked to each group. So UV, X-ray, and gamma, they are all ionizing. Gamma is the most ionizing, it can cause cancer. UV is the least ionizing, and it can cause sunburns, and overexposure to UV light over a very long period of time can lead to skin cancer. So here's the answer. UV light or ultraviolet light, X-rays and gamma rays can cause mutations in genes. Ultraviolet can cause skin to age or can cause skin cancer, and X-rays or gamma rays increase the risk of cancer. Figure 5 shows a person using a mobile phone to allow a laptop to access the internet. The electromagnetic waves emitted by the mobile phone send information to the laptop. The electromagnetic waves emitted by the mobile phone have a period of 4.0 times 10 to the power minus 10 seconds. Now, wave period is given the symbol capital T. Calculate the frequency of the wave. The equation that links wave period and frequency is wave period equals 1 over the frequency of the wave. So 4 times 10 to the power minus 10 equals 1 over the frequency. So frequency equals 1 over 4 times 10 to the power minus 10. That gives me 2.5 times 10 to the power 9 hertz. 2.5 times 10 to the power 9 hertz. The electromagnetic waves are produced by oscillations in the transmitter of the mobile phone. Explain how oscillations in the transmitter enable information to be transferred to the detector in the laptop. Now, this is a question that most students fail to or struggle to gain full marks. They seem to gain a couple of marks. So let me show you the answer and then I'll give you an explanation as well. So here's the accepted answer. Radio waves are produced by the transmitter. 1 mark. The detector absorbs the waves or the energy, which produces an alternating current with the same frequency as the transmitter wave. So how does this actually work? So let's say you have a transmitter here, shaped like a cup, and you're sending out waves in that direction, and it spreads out. And you have a receiver or an antenna on this side. And when this wave hits the antenna over here, it creates an alternating current on here. So this is the transmitter. And this is the receiver. So the radio waves that are produced here, so these are radio waves, right? And the detector or the receiver, right? We can call it the detector as well, right? The antenna absorbs the wave, which produces an AC current as the same frequency as that. Now again, I think it's still hard for some students to understand how this is actually happening. So imagine you are on a big lake and the water is actually really calm, right? Now, if you start making waves, right? Let's say you have a duck, a rubber duck. How do I draw a rubber duck, right? Right. Let's say I have a rubber duck here on this side, and on this side, I'm going to start making a wave by pushing the water up and down, right? It can be in a swimming pool or even in a bathtub. I think a lake is far too big. So let's say you have water in a bathtub, and this is one end of the bathtub, and you have a rubber duck on the other end of the bathtub. And you use your hand to push the water up and down. And that would create or disturb the wave, and it'll create a transverse wave, right? Now, that wave is going to move over. And when it comes near the rubber duck is actually going to start moving up and down. Now, the number of times the rubber duck moves up and down is going to be matched by the number of times you are pushing the water up and down as well. And that's actually the frequency. So if you push the water up and down, let's say once every second, that rubber duck, when it starts moving, is going to go bob up and down once every second. And that's exactly how this also works. You're sending a wave with a certain frequency, and that frequency travels through a medium here in the air, and it's absorbed, and it creates a AC current in the same frequency. Hope that helps you to understand this question, because generally these types of questions are quite hard to interpret. But the good thing is I've seen this similar question at least 3 times in the last 6 years. So they do ask periodically to make sure that the students actually understand how waves are transferred. That brings us to the end of question number 3, and I will see you in question number 4.